All right, cool. So any final takeaways on homework 7, and then we'll talk about homework 8. Um, but what do people think of dialogue? Um, as far as usability, interesting, fun, annoying. Had fun with it. Easy to use and fun. Interesting and annoying. That's probably a good way to describe it. Um, yeah, fun but annoying at the same time. It's it's not what you would use for like production ready code. Although like if you get a Raspberry Pi and you run Raspi config, it's the exact same kind of dialogues. I wouldn't be surprised if it actually used dialogue or some variant inside. I mean, before everybody had PCs that they were running their system on, right? Most displays were 80 by 24 characters, or maybe 120 by 24 or 25, and that's how graphics was done. And it was really a big deal when suddenly you could display things that looked like boxes and stuff instead of just letters made out of asterisks. So the introduction of graphics character sets, and this was common on old VT100 terminals, let people do things that looked like they were interacting with a graphics display, even though they were running what would be called typically a dumb terminal, meaning it was unembellished. It just displayed characters in fixed positions on the screen, and that's how a lot of graphics was done. That's what the earlier versions of Windows, I think, looked like. Let's see, I just have to wonder who it was made for. If you have a GUI available, you're going to use that. And if you only have text-based environment, you're probably comfortable in that environment anyway. Well, maybe, maybe not. Again, think about a different era when most people did not have, equipment that could display a general, graphical output, but still wanted to be able to interact with things that had menus and mice were starting to appear as a thing, but you would navigate with arrow keys and select with a space bar. Think back to like using the Lynx browser, which is the same idea, right? How do you make a web browser when there's no mouse and there's no graphical output? Well, that's where Lynx is, right? Um, so it's not something that you would use if you were trying to make a professional front end, but if you want to have something between a full-blown GUI and command line interaction, this can fit the bill sometimes. But yeah, it's definitely it's not as customizable as one would like, and so on. On the other hand, it has zillions of switches, um, and you can do a fair amount of tailoring of it. Is dialogue something that's going to be on the final? I'm going to say yes for now because I do not want people to toss this out of their brain. Although I'm not sure exactly what questions I could ask, but I mean, I might ask you, some questions about specific types of dialogues. How do you make a calendar using the dialogue command, something like that. So I'm going to leave that on the list of possible topics for now. Um, but yeah, the main point of homework 7 was just kind of more practice with putting commands together, working in Bash, and dialogue was a bit of an excuse to do that. Um, all right, so and at least one person had a question about homework 8, so let's go with that. Yeah, test 4 takes a long time, but it does work awesome. Yeah, it's a huge file. It's 600,000 bytes of input. That's not a good file to do your initial debugging with, obviously. Um, but once you're pretty sure that everything is working, go ahead and run that. Come back in a few minutes and do a comparison. Make sure it's giving the right output. Um, can you show an example of setting up an associative array? Yeah, we can go through some examples of that again. Um, let's Let's do this from the command line. So I'm just sitting at a bash prompt right now. I want to make an array. So I'm going to say declare -a, and then the name of my hash. What am I going to call it? I'm going to call it map. Okay. So the setup I'm thinking of here is I have this array called map, and I can index it with some key, and that's associated with some value. All right, so we're thinking key value pairs. In a regular array, we call this an index, right? But index generally means, you know, a consecutive integer starting from 0. So we can call this a key, and the value is the thing that's stored at this location in the array. All right. So let's store some stuff in our. Well, let's look at the contents of our hash first. So echo $map. You know. That's not what I wanted to do. All right. So this funny notation, $curly bracket, and the name of the array, and then square brackets and the key or index inside there. That's how we're going to access elements in this array, right? I have no element associated with the index endicott, right? This is an empty array. I just declared it a moment ago. There's nothing in there, so anything that I try to pull out of there is going to come out blank. But I can store values in there, right, by saying something like map bracket quote endicott equals, and I'll say endicott is in New York. That's where I grew up. All right. And now if I look at the value indexed by that key endicott, it pulls out the value New York. All right. So I can say something like map bracket Vancouver is in Washington, and map bracket Portland equals Oregon. All right, so I have this array called map, and I can say, you know, show me what's stored in there at the index Portland, and it's got a value associated with that. If I ask, you know, for the value stored with port _land, there's nothing stored at that value, right? If I ask for the value associated with Vancouver, right, that pulls out Washington. So I have this array. In this case, it's got 3 values: map bracket Endicott, map bracket Vancouver, map bracket Portland, right? And each of those values is associated with that particular index. So for homework 8, what are we doing? We're storing phrases, right? So our keys are our phrases. We find a phrase which says good morning, and so we say, you know, phrase dictionary bracket that phrase equals, and we set it equal to 1 to say we've seen this phrase once. So yeah, the keys will be the phrases, and the value will be how many times we see it exactly. And so each time you see a phrase, what do? Pull the current phrase out of your hash to see how many times you've seen it, add 1 to that count, and then write it back. Right? And this is something that we'll talk about a lot sometimes. This is what we call a read, modify, write operation. Right? This is what most things are inside a computer: read, modify, and write. So we read the current count, right, the current tally for how many times we've seen that phrase. How do we read that? Well, we say something like, you know, value equals $map bracket phrase, right, or $phrase. And then we modify it, so just increment it by 1, so count equals $paren count plus 1. And then we write it back in by saying something like, you know, dictionary bracket $phrase equals, you know, that count. And if I try to echo $map, I don't really get anything, right? Map is an array, but it's accessed using this structure that's described in the assignment. So for what are our keys in here? I guess our keys are cities. So for city in, and then we say exclamation mark curly bracket, $, curly bracket, exclamation mark, name of the hash, bracket, amp, @sign, right? And this is just how you do it, okay? Don't necessarily try to understand why that syntax makes sense, right? It probably does, but that's what you call above our pay grade. So for city in that, let's just echo the value of the city, right? So that's a for loop that runs and it shows me my 3 keys, right? Not in any particular order. And so if I wanted to do something more interesting with this, I could say echo $city is in, and then I could output the value of my associative array indexed by that key. So I could output $curly bracket, map bracket, $city, close, and a close quote. And it tells me Vancouver's in Washington, Endicott's in New York, etc. So how does this relate to homework 8, right? You do all of your parsing, you read a line of input, you clean it up, convert, change the phrases into things with underscores and have them space separated, and you do that for loop that says extracting phrases where you iterate over each phrase in that input line, right? And now for each of those phrases, read the current count from your dictionary, right? So look at $dictionary bracket, whatever you call that phrase, right? Get that variable, increment it, write it back into the hash, right? Say hash bracket phrase equals that new count. And you do that across all of the input. Once you get to the end of file, once your while read line loop exits, then you want to go through and you want to pull out your phrases and print them out. So you make a for loop like that. And then inside there, take the current phrase, right, that's the key, change the underscores to spaces, that's a sed line, put that in a temporary variable, and now output the current count, which is, you know, the value stored in the hash, followed by a space, followed by the phrase. And you're done. That's homework 8. You do not need to initialize the associative array. So suppose that instead of cities, suppose I was storing counts of phrases. So let's say, you know, phrase, new phrase equals hello there. I'll stick to underscores. Doesn't matter, you can do spaces. So suppose that this is my new phrase that I just parsed from my input. So new phrase is hello there. And I'll just assume my collection of phrases is in an associative array called index. All right. So I've read my phrase. Here's what I do. I want to store this phrase new p into my dictionary called index. Okay. I'm going to do a read, modify, write. Okay. Just to keep things clear for myself, I'm going to make a variable called key, okay? And I'm going to use key to access a value from my array. So I'm going to say value equals $curly bracket, index bracket, quote, key. Okay? I'm doing this for clarity of my own mind. Really, I could have just used new phrase in here. But I want to reinforce this idea that this is an associative array. I put in a key, I get out a value. Okay, what's the key? It's whatever phrase I have. The value is the thing that's stored there. Okay, so I'm going to pull out basically how many times hello there is in my index. Okay, if I look at the current value, it's missing, right? Because that phrase does not appear in my index. But if I echo $paren value plus 1, I get a nice clean 1. So an empty line plus 1 is the same as 0 plus 1. Okay, so I'm going to say something like, you know, new count equals, and I don't have to do this, I can just say new count equals value plus 1. And then I'm going to store this back into my index, so index bracket key equals new count. Alright, so now I've got one phrase in my index. I should have saved $new count. Alright, so now I've saved a 1. So the next time I go in here and I say let's find how many times this phrase has been saved, let's add 1 to that and set that equal to new count, and let's store that back. So now if I come along later and I say how many times have I seen hello there, I've seen it twice. Alright, so I don't need to initialize, and I couldn't initialize unless I knew what every phrase was going to be. But by default, if you try to access with an index that doesn't exist, you just get back an empty line. Alright, good stuff. Other questions? Let's see, so someone says, when iterating a phrase from just a line, do we stop when there is a space? So yeah, assuming that you've cleaned up your input line, so this is what your line is going to look like. Okay, so suppose you had a line of input and it said, hello there, comma, this is a test, period, goodbye, exclamation mark, ha ha ha, right? All of the pre-processing and cleansing that you're going to do is going to convert it into something that looks like this, right? First phrase with no spaces in it, and then a space, second phrase, space, third space, phrase, space, fourth phrase. So each phrase on this line is separated by a space. And this lets you do the following kind of for loop for one phrase in $phrases, do and inside my do loop I'm just going to output the value of one phrase. I misspelled echo. Right. So now I'm looping through, I'm iterating on the contents of that phrase, and each time through this variable gets assigned the next space separated piece of this input string. So that's an easy way to iterate. So yeah, so the space basically signifies something that delineated one phrase from another. Could be a period, question mark, whatever. Okay, there's other ways you can make this work. This is, I think, the most straightforward, and it uses, you know, some core ideas that I think it's important to know about Bash, like the idea of a for variable in a string of things that are separated by spaces. But there are other ways you can do this. If some other way is making more sense to you, you know, feel free to modulate this. There's this whole notion of an input field separator, which by default is white space, But we could change our input field separator to be something like a period, and then we could separate these phrases with periods and do something like that. So you're not necessarily bound to this particular approach, but I think this one is pretty straightforward. All right. Other questions? So let me make sure. Let me make sure that we're good on doing input. Alright, so this is just sample code, right? So bash scripts. We're going to say entering input loop, and then we're going to go into this while loop, which says while read, and I've got the name of a variable here, just called variable. This is going to do a read variable statement, right? But each time it reads a line, it's going to go ahead and execute the body of this loop, which is just going to do an echo of what that variable is, and it's going to keep iterating over this until it hits the end of the file. And then it'll come out of this loop and it'll say done with input loop. Right, so I can say hello, testing 1, 2, 3. And then Control D at the end of a line takes me out of that. It causes the while read to come back with false. If I hit Control D at the end of a line, it doesn't work, right? It triggers end of file if you make Control D the first thing on a line. Oh, that was weird. But if I hit it twice, that does seem to kick it out. But it kicks it out without that read coming back and giving me a line. So when you're using Control D to signal end of input, always put it the first character on a line, right? Control D is not actually anything magic. It's just something that's, by convention, treated. If you see Control D as the first thing that's typed on a line, things that are reading it will respond as if it's hit the end of the input stream. Right, so get car and fgets and read and bash and all these other things treat Control D that way from the input. But if you read from a file, right, then while read variable is going to read line by line the contents of this file, because this file is what's supplying stdin. And when the file has been completely read, the next time that read executes, it will say end of file, and it'll kick out of that while loop, right? So this goes through and it reads the contents of that file. Right. So this is just a standard read statement, right? So you can put a -p for a prompt. You could put a timeout on there. You could do a -n to read a single character, and so on and so forth. All right. So I want to go through and hit some other things related to bash and start talking about processes, and then loop back and talk more about awk. But just some useful things to know. $random is a thing. It's a variable built into bash. Every time you echo it, you get a random value. That, you know, is not anything that we need right now, but it's a good thing to have, because if you need a random value, it's hard to generate one on your own sometimes. So that's always an option. Scoping of bash variables. And we've touched on this before, I think, but let me do it again here officially. All right, let's set a variable here, message equal to hello, and then let's echo the value of that, right? So I'll make this script executable. I do that, and MSG is equal to hello. But if from my command line prompt I look for the value of MSG, it's not equal to hello, right? Even though, you know, when I ran the script, clearly MSG got set to hello. Right? I mean, there's nothing simpler than that assignment statement. But yet when I echo MSG, it's not equal to hello. Okay? And this is a feature. And the reason this is happening is because here's my command. Let me call this command line bash. This is the bash program that's running right now. And the bash program that just printed 2012 inside brackets and is waiting for me to type something in. When I type in, you know, the name of a script, the system creates a new bash process which runs the script and then comes back. So that assignment of the variable MSG happened in this entirely different process, right? This bash with its own memory space, its own set of variables, set MSG equal to hello, right? But once that script exited and I came back here, right, nothing had changed the variable list inside my current bash session. So this is the first thing to think about, is that every time you run a command, it runs as a separate process. All right. The next thing is, and this is kind of related, suppose I don't give MSG a value, and I run this, message is just blank. We expect that. Now if here I say, you know, message equals haha, and I run my script B, again, message is blank. Why is that? Exactly the same reason. Because over here, I said message equals haha. But when I typed in the name of my script, a whole new session started, a whole new process running bash. And when bash starts, MSG does not have a value. So this executes my bash RC file, and that might give some things values. But when the script starts to execute, MSG has not been assigned a value. Now I can override that. I can say export and the name of a variable, and I can cause that variable to be inherited by new shells that get created. So if I say export MSG, now when I run my script, MSG has a value. And that's not really magical, right? When I say export, basically I'm saying if you start a new bash process, before that thing starts to get too far in its execution, make sure you copy the value of MSG into its list of variables. So yeah, the command line is like its own bash script, and if you run a command, that runs as a separate process. So we can export variables from here into that new process, but it's extremely difficult to pull variables back, to execute this script and have it update the value of a variable and have that come back, because it's a totally separate process, right? And processes are kind of their own thing. So there's the value of message. Here's my script, which changes the value of message, but it didn't change in here. All right. Now there's one way that we can circumvent this, is to use the command source. So if I just type the name of a script, new bash process is created, that process runs my script. If I say source in the name of a script, that script executes in my current bash environment. And my current bash that's sitting here will basically read that file line by line and execute each of those commands. And so while running the script B doesn't change the value of MSG, if I say source B, right, now if I look at the value of MSG, that's changed, because when I said source B, my current shell basically executed these commands. First one was a comment, second one did an assignment of MSG, the third one echoed the value of MSG. So let's say I want to change the value of my prompt, right? So I've changed my prompt to have haha in the beginning of it. Well, my prompt does not have haha in the beginning of it. And I can try to execute my bash RC and you know, I get weird stuff, and my prompt has not changed. If I say source and execute bash RC, it executes the statements in that file from my current bash session, and that changes my prompt. And that's probably the main thing where I've used source. Is for testing your bash RC and such. And remember, bash RC is where you can put all the things that you want to have happen when you start a new bash session. So initializations and things like that. All right, mostly a reminder here. Standard in, standard out, standard error. So input and output in bash is mostly done through what we call these IO streams. And there's three standard streams that are set up for us: input, output, and error output. And when you say read from bash, when you say fgets from C, when you say getcar from C, those are all reading from something called standard in. And standard in is usually your keyboard. Usually if you type something on your keyboard and hit enter, that goes into standard in, and something that's saying read or fgets will ingest that. Okay? But if you run a command and you say less than file name, standard in has been redirected. Okay, that less than sign is a redirection, and now standard in is coming from that file. And if you say something like, you know, date, pipe into, you know, some command, when this command executes, its standard in is not the keyboard, it's the output of this command. Okay, standard out is where things normally are sent to. So when I say date, date is written so that it figures out the current date, makes a nice looking string, and then sends that to standard out. Well, standard out is normally my display. But if I say date and I send that into a file with, you know, a greater than sign, standard out for this command has been changed. And standard out is now this file C. And if I say date pipe into word count, right? Standard out of date is now going into standard in of this command, word count. And word count is written to read standard in, count how many characters, words, and lines, and then output to standard out. So this is why piping works, right? We're really connecting this output stream to this thing's input stream. And if I take this and I put that into a file C, word count standard out has been modified to say right into a file. And now if I look at that file, it's got the output of word count processed as input the output of the date command. So even though we normally read from the keyboard right to the display and errors go to the display, there's really three sort of pipelines, right, for information flow in Unix. Now we can make more pipelines. We can create our own streams by using things like fopen or open, and we can interact with those by putting different arguments to, you know, fgets or fprintf or things like that. And we'll touch on that later because we'll need that in winter. But that's basically what those three standard streams are. All right, so I just wanted to touch base on those. Let me mention one other thing in here. If you're trying to debug, putting a -x at the end of your shebang can be helpful. Alright, so this is just a junk script. Gonna set message to hello, I'm gonna set I to 5, I'm going to go into a while loop, output the value of message in I, and then increment I. With my -x in that first line, which is a verbose command, right, I get a lot of additional output in here, right? I'm seeing that message was set to hello, I was set to 0, I'm executing an if statement, I'm doing an echo statement, there's the result of the echo, and then I set I equal to 1. So yeah, this can help on homeworks related to bash questions, bash programming. Now you probably want to throw in some print statements in here, some echoes to help you know where you are in the file if this is not unambiguous. But it'll show you when variables change value and things like that. It produces a lot of output, right? So be prepared for that. But in terms of knowing, you know, what's going on, it saves you from putting in a million echo statements. So that can be useful. Let's see. All right, let me mention one other thing. Again, this is not something we particularly need for this assignment. But our if statements, you know, mostly we've done, you know, something equals or something is less than something. But there's a bunch of conditions you can put in here related to files. So for example, we can say if -exist file. And this will let us do a bash statement that tells us whether or not a file exists. So I could say, you know, if a file named haha exists, then echo funny. But we end an if with a fee. Alright, so if a file named haha existed, then it should echo the word funny. Well, it didn't echo the word funny because I don't have a file named haha. But if I make such a file and I execute that same if statement, right, it tells me that file exists. And if I remove that file, then the -exist will come back with false. So this can be useful when you're dealing with temporary files. If you want to know if a file by this name already exists, you can check it like this, and so on and so forth. And there's a whole bunch of these things. If you do a man on bash, this is a huge manual page, and it takes some searching, but you know, you can do a slash and search for things like that. And so here's a bunch of options you can use on files. If the file exists, if it exists and it's a directory, if it's a character file or a block special file, which is a device, right? All sorts of options there. If one file's newer than another, and so on. So just tossing out some things that may be useful, you know, not necessarily homework 8, but down the road in bash. All right, so tomorrow we'll start in earnest looking at processes in bash, and working with processes using different bash commands, and then we'll go back to awk, and then we'll talk about processes from C. All right, have a good one. I will catch you tomorrow.